Okay, here's a tricky probability question. Lots of things you need to pay attention for here. We're taking two apples out of the box, and the key thing is that it's without replacement, so the probabilities will change when we go from the first apple to the second apple. We're looking at the probability that both of Nick's apples are bad. Well, the probability the first apple is bad is the 3 bad apples out of 10. So there's a 3 in 10 chance that he'll pick a bad apple the first time around. For the second time, how many apples are left? Well, there's no replacements. There's 9 apples left in the box, of which how many are bad? Well, you've taken one bad apple out, so there's 2 left. So the probability of getting another bad apple, probably the second apple is bad, given that the first one's already bad, is 2/9. So you multiply those two together, that's the probability of getting a bad apple on the first go, and then probably to get another bad apple afterwards, and that comes out as 6/90, which obviously cancels down to 1/15. The probability that at least one of Nick's apples is good. Now, this is a very important phrase in probability. At least one. If you're working out the probability of at least one of something happening, that means it's all the probabilities apart from none of them are good. So we could go through all the different ways in which you could get 1 or 2 good apples, but the easiest thing to do is look at the probability that none of them are good, which is the answer to part 1. If the probability that none of them are good is 1/15th, the probability that at least one of them is good is everything that's left over from 1/15th. So it's just 1 minus 1/15th, or 14/15th. That's the quickest way to answer that question. You can go through all the different ways of doing at least one, but the easiest way to work out at least one is to work out the probability of none and then do 1 minus that. So at least one, probability of at least one equals 1 minus the probability of none. I hope that makes sense, because that's a very important concept. The last question as well, people found quite difficult. Another box contains 8 good and 4 bad oranges, so 12 in total. Crystal keeps taking oranges at random from the box one at a time without replacement until she gets a good orange. So that means that she's going to take, if she gets a good orange the first time, then she finishes. If she takes a bad orange out and then a good orange, she finishes. If she takes bad, bad, good, or bad, 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 good, she basically takes out as many bad oranges as she can until she gets a good one. So the probability that she takes out exactly 3 oranges, what that means is she's going to take a bad orange out, and then another bad orange out, and then a good orange, and because she's got a good orange at that point, she's going to stop. The probability that the first orange is bad is there's 12 oranges in total, of which 4 are bad. Having taken a bad one out, there's going to be 11 left, of which 3 are bad. Having taken 2 oranges out, there's 10 left, of which 8 are good. So the probability of getting a bad followed by a bad followed by a good is that it simplifies to whatever it simplifies to, a half or something around that.